Hello guys, welcome back to TechDose, and in this video we will look at maximize subarrays after removing one conflicting pair problem, which is from Leetcode number 3480. Let's now read the problem statement. In this problem you are given an integer n which represents an array nums containing the numbers from 1 to n in order. Additionally, you are given a 2D array conflicting pairs. Conflicting pairs at I represents a comma b, which indicates that a and b form a conflicting pair. Remove exactly one element from the conflicting pairs. Afterward, count the number of non-empty subarrays of nums which do not contain both a and b for any remaining conflicting pair a comma b. We need to return the maximum number of subarrays possible after removing exactly one conflicting pair. Now let's look at the first example. In this case, the n value is equals to 4. So you can assume that on a number line you have the values 1, 2, 3, 4. So the limit is given from 1 to 4, where you can say that the start point is 1 and the end point is 4. Okay. Now the intervals which are mentioned, you can say intervals or conflicting pairs. So the first conflicting pair is 2, 3 and the second conflicting pair is 1, 4. Right. Now let's say that if you had removed one of the conflicting pairs, like what do we now in this case, what do you even mean by a conflicting pair? So if you take an interval 2, 3 and you create a pair which starts somewhere to the left of 2 including 2 and ends to the right of 3 including 3, you have an s1 e1 pair, then this will become invalid. Like if I write 1, 4, this becomes invalid because this is containing both 2 and 3 inside it, right? Within this interval both the conflicting pair 2, 3 is present. The pair is present. That is why 1, 4 becomes invalid. Whereas if you write something like 1, 1, then this will be perfectly valid. And if you had written, let's say something like 4, 6, then this will also be valid because 4, 6 do not contain both the points 2 and 3. Even if you write 1, 2, it will be valid because it do not contain both 2 and 3, right? It contains only one of them. And so 3, 5 is also valid. So that is the meaning of valid subarray or an invalid subarray when you talk about a conflicting pair. So in this case, the problem was asking about exactly removing one of the conflicting pairs. Let's remove this one is the conflicting pair 2 and 3. If you remove this 2 and 3, then how many valid pairs can you make? Valid subarrays can you make? You can make 1, 1 as valid because the leftovers pair is 1, 4. So if your interval exactly contains both 1 and 4, then only it becomes invalid. So 1, 1 is valid, 1, 2 is valid, 1, 3 is valid, but 1, 4 will be invalid, right? So the count of subarrays that you got starting with 1 is 3. Similarly, starting with 2, you can get 2, 2, you can get 2, 3, you can also get 2, 4, because starting with 2, you are not including 1, right? So count is 3. Again, starting with 3, you can get 3, 3 and 3, 4. So 2 count, and starting with 4, you can get 1 count. So the total valid subarrays you get is 3 plus 3, 6 plus 2, 8 plus 1, 9 after removing the smaller conflicting pair. Now let's say that you had kept the smaller one and had removed the larger conflicting pair. Then in this case, how many subarrays would you form? Starting with 1, you can form 1, 1, 1, 2, but you cannot make 1, 3 because that will contain both 2 and 3. And you can also not take 1, 4. So the total count you get at 1 is only 2. Similarly, at 2, you can only have 2, 2. You cannot have 2, 3 or 2, 4. So 1 count for this. For 3, you can have 3, 3, 3, 4. So 2 count. And at 4, you can only have 4, 4. So 1 count. So the total count will be 2 plus 1, 3 plus 2, 5 plus 1, 6. So if you had removed the larger conflicting pair, then you get 6 valid subarrays. And if you remove the smaller conflicting pair, in this case, you get 9 count. Which one is maximum? 9 is maximum, and that is why 9 is the answer. Okay. So I hope you have understood the problem. What is the meaning of a valid subarray and what exactly the conflicting pair is doing, right? So we can try to remove each of the conflicting pair one by one. Let's say there can be m number of such pairs, and you can try to remove each of these pairs one by one. When you remove a pair, then you need to traverse and calculate the total count that you are getting by traversing through each point one by one, right? So as I had shown from 1 to n you can traverse by removing an interval. There will be other intervals as well. By removing a conflicting pair, you need to traverse for each of the point 1, 2, 3 and so on till n, and find out the count contribution for each of these numbers, right? So if you do that, then you will be doing it in order of n times m, nm time, right? Where m is the number of pair and n is the timeline, which is from 1 to n. Now if you also apply certain strategy and say that okay, I will be arranging all these m pairs and then I will be directly calculating how many valid subarrays are there inside it, then you can do that. If you know the subarray size here, which is equals to, let's say, k, then the number of subarrays that you can get is k into k plus 1 by 2. With a subarray size k, the number of total possible subarrays that you can make is k into k plus 1 by 2. So you can go to each of the interval and find out the count and add it up, right? So in the worst case, again you can be going through n number of points or n by 2 number of points, so it will come out to be the same as nm, right? Now in our problem statement you will see that the n value is 10 to the power of 5 and the conflicting pairs length is also 2n, so both are equivalent to n. So if you write an nm or an n square algorithm, then that will be 10 to the power 10 computations, which will give you TLE, because 10 to the power 8 is the standard for 1 second, so you need to have computations less than 10 to the power of 8. So in this case, an order of n log n or m log m or something better than this would be the one which we will need, order of n or n log n, right? So I hope the entire constraint and the problem is clear. Let's now look at some observations. You already know that the number of subarrays of a segment size n will be n into n plus 1 by 2, because if you take a segment 1 to 4, then you can find out all the subarrays starting with 1, that is 4 count, starting with 2, 3 count, starting with 3, 2 count, and starting with 4, 1 count. And if you add it up, it will be n into n plus 1 by 2. Here it is 10. Now in this problem, the input may not be in the correct order, so we need to create the input in correct order, that is in the low high order, so that you can apply certain algorithm on it. So if you run through this entire process, then you will find certain test cases are not following the order. 8, 4 is not valid because 8 is to the right side and 4 is to the left side. So you may have to rearrange this entire thing. So parse through all the points and see that if the first value is greater than the second value, then swap the values. Okay, so 2, 5 is in correct order, but 8, 4 needs rearrangement. So it should be 4, 8. This has to be done before applying any algorithm, right? Now let's try to understand the intervals in terms of matrix using XY plane, on an XY plane. Let's see. Let's say that our n value is equals to 10 though, so our timeline will be from 1 to 10. The first conflicting pair 2, 3, second one is 6, 8. Now I can always mark the conflicting pair on a matrix, and let's say that I mark this pair A as 2, 3. So how is this matrix built? The matrix column side is the start and the row side is the end. So when I say 2, 3, then I will go to the second column and the third row and mark the interval A here. What is the meaning of this? It means that if you have any point in this shaded area, then it will all be invalid. It will all be invalid. And how is this even possible? Let's say that you have taken a point 1, 5. What is the meaning of this 1, 5? 1, 5 means you have an interval from 1 to 5. Now if you take an interval from 1 to 5, will you not contain 2 to 3 interval in this? Yes, you will include it. 2 to 3 will be inside it, right? So that is why it will become invalid. It will become invalid if you take another point, let's say 2, 10 here. So 2, 10 will contain 2, 3, right? So this entire shaded area will always contain 2, 3. So all of these points will become invalid if you are considering this interval A. Now what about this 1, 2? This 1, 2 do not contain this entire interval 2, 3, and that is why this will become valid, right? So you can understand it visually using the matrix. If you look at the second interval again, B 6, 8, then see I can mark 6, 8 here, and so all of these cells will become invalid. So if you take any cell like let's say 4, 10, 4, 10 will entirely contain 6, 8. So this becomes invalid, right? So in this particular case, since I always know that the start is less than equals to end because of this rearrangement that I had done, this part of the matrix will never be used. This part of the matrix will never be used because the start is always less than equals to end, right? So I hope this entire representation is clear because the solution will be based on this. Now once you have understood that, let's take an example. Here I have taken an example having 5 points and I have represented all these 5 points along with their corresponding names of the intervals, right? So this will be given in the form of a 2D array, right? So if you look at it, point E is 2, 3. Okay, point A is 4, 5 and so on. Now in this case, whenever you think about applying any kind of algorithm, definitely you need to apply in certain order, whether you apply top down order or you apply left to right order, whatever order you apply, you need an order on it. So in this case, I will be applying top down ordering for processing. So I need all the points to be coming in the top down order. What is top down? Top down is actually your end value, right? Top down is your end value. So I will be sorting all these points based on the end value. So if I sort it based on the end value, then E will be the first point that I encounter. Now our goal here is to find out the maximum profit interval, which means that if you remove an interval, if you remove a conflicting pair, I can only remove exactly one conflicting pair. So if you remove a conflicting pair, then how much profit do you make? That means how many subarrays become available to you. If you see, I have shaded all the area. For this point A, this will be entirely invalid. For this point E, this will be invalid, right? So if you closely monitor, then E and A have this region in common. This means that even if you remove this interval E, still this will remain to be invalid because of A, right? Now if you see this region is common to E, B and A. So this means that even if you had removed E and A, still this will remain to be invalid because of B, right? That is the meaning of it. So whenever I remove a interval, like let's say I remove E, then it will only free up this space. How many cells it is freeing up? Only 4 cells, because this is not getting affected by any other interval, any other pair, right? So if I remove E, then I make a profit of 4 subarrays. 4 subarrays, that is 1, 3, 2, 3, 1, 4 and 2, 4, right? So I make 4 profit. Now once you have calculated for E, we will put back E in its place, and now I will try for A. If you remove this A, then how much profit do you make? You cannot make all this profit because these 2 cells are also blocked with E and E is present. So if you free up A, then these 2 cells will be one you recover. These 2 cells, 2 plus 2, which is 4, 4 plus 2, 8, 6, 6 plus 2, 8. And after 8, you will be making 9 and 10. So you are making 10 profit total, right? You are making 10 profit. So after removing A, you made 10 subarrays. And then you will again put back A in its place and try to remove B. When you remove B, then how many profit are you making? You will not make any profit, because after removing B, these all cells should be freed up. But you see that these all cells are also covered with E and A. Actually, A entirely contains this B. So after removing B, you are not making any profit. After removing C as well, you will not make any profit. And after removing D, the profit made will be these 3 cells plus these 3 cells, because the rest of the cells are covered by A. These all cells are covered by A itself, right? So 6 will be the profit. Out of all these options, which one is giving you the max profit? The 10 is the maximum profit that you get. So maybe removing A would be the best option for us, right? So our goal is for each pair, remove and check the gained subarrays, and the pair with the maximum gain will be removed. The interval with the maximum gain will be removed, isn't it? So that should be our entire idea. Now let's see some cases which will help us implement this into our code. So let's say that I have created 3 different scenarios, and in this case I will be calculating what will be the profit on removing B and how to calculate all these profits. So on removing B, in the first figure, you look what A is covering and what B is covering. If you remove B, then this will be your profit. This will be the gained subarrays. How do you calculate that? You will be calculating this region by finding out this gap. This gap will be the next element's baseline, and this element's baseline, you subtract them, right? So you can find the gap from the coordinates. When you found the gap, then you have to see that if this is, let's say, S1 and this is S2, then you find out the gap between S1 and S2. So your gain will be equals to S1 minus S2 times gap. That will be your profit after removing B. That should be the case, right? If you look at the second case, B is entirely contained inside A. So if this is S1 and S2, then S1 is less than S2, and so the gain will be 0 only. There will be no gain. If you try to calculate it with this formulation, since S1 is less than S2, it will come out to be a negative number, right? In the third case, if you see, if you remove this B, then removing this B, you cannot just directly calculate by saying this is S1, this is S2, and I will say S1 minus S2 into gap, because the gap will always be calculated not with this baseline but with the next point's baseline. So the next point is C. Let's say that the C has S3 and these all points were like, let's say, E2, E1 and E3. So the gap here will be equals to E3 minus E1, right? So when you calculate E3 minus E1 multiplied by S1 minus S2, you will get this shaded area, only, okay? This shaded area. But is this the one that you make profit after removing B? No. You have to also calculate when you reach to C. Then you need to calculate this part as well. So when you reach to C, how will you calculate this part? The C's S value is S3. Okay, and S3 is lower than S1. So removing C will not contribute anything. Instead, C is entirely contained inside S1, which is B. So what I will do is I will maintain the maximum out of these two, which is S1. Maximum out of these two, take S1 and subtract it with the S3. In this case, it will be S3, right? And then multiply it with the gap. What is the gap? This will be the gap, okay? So then you will get the shaded area. This is how you calculate it. Now let's say that there was another scenario where you had something like this. Something like this was present, okay? Then if you are present at C, then this entire thing should not be calculated. Instead, this region is what I will be looking for. And if you are looking for this region, then what will you do with S3? If this was S4, then what you will do is you will be doing S1 minus S4 multiplied by the gap, and this is your gap, the same gap, right? So gap will be same, but you see that the region will depend on when you had moved top down, then the maximum and the second maximum. So I will write max 1, max 2. This shaded area, what you want to calculate, will depend on when you were calculating top down, then what was the maximum S value and the second maximum S value that you saw, because that will be defining how much of the shaded area will be freed up. It will only depend on maximum and the second maximum. So all the other points are of no significance. When you move top down, only the maximum and second maximum are of significance. If you try to write it, then you will understand what I'm saying. Also, if you look at the first example, when I move top down, when I see this point A, then I'm not seeing this point B. Okay, when I process this point A and I say that I will be freeing up this space, then I will be calculating the gap here, whatever is the gap, and I will be taking S2 minus 0 because the previous S value is 0 because there is no previous point, right? So in this case, the freeing up space will be simply whatever is the S2 value multiplied by the gap. So this will be the shaded area. If you free up A, then this shaded area will be what will be freed up, isn't it? Now, what will be the blocked space? Because I need to also calculate the block space. If you look at the previous matrix here, then the n value was equals to 12. So how many total number of subarrays are present? The total subarrays will be 12 times 13 by 2, n into n plus 1 by 2. So if you calculate, that will come out to be 78. So if there are 78 subarrays, I mean you will have 78 subarrays in n value 12, which is array of size 12. Out of this, what you have to do is, in total subarrays are 78. This is total. From this you have to subtract the blocked subarrays, and on this you have to add the profit. What is the profit? The profit is actually equals to, when you free up a conflicting pair, then how many subarrays become valid which were previously invalid. How many of them become valid when you free up a pair, isn't it? That is your profit, because I can free up a conflicting pair. If I could not free up a conflicting pair, then all this blocked region will be the one which I will be just subtracting from the total number of subarrays. Okay, so you should know that from the total number of subarrays, I will be removing the blocked subarrays, and I will be adding, what is the blocked subarray? Blocked subarray is this area of the shaded region, Now, since you can free up a pair, so some of the shaded region will become unshaded, and this will become valid, and that is why the profit has to be added. I hope this point is clear. So in this case, once you move top down, you have to always keep adding whatever is this gap, whatever is this shaded area, right? So the shaded area is always equals to the maximum S value that you have seen multiplied by the gap. This will always keep on adding to the shaded area. Blocked is actually the shaded area. So in this case, S2 into gap will be added, S2 times gap will be added, and the next time when you go to B, then the gap is, let's say, gap 2, and in this case the difference will be S1 minus S2. So this S1 minus S2 times gap 2 will be actually the one which will be freed up when you remove B. But if you think about the blocked region, then the blocked region will be calculated by the maximum S value that you have seen till now, which is S1 times the gap. So S1 times gap 2 will be added, and this will become the total number of blocked subarrays. Okay, so I hope you have understood the idea. Now let's look at a dry run and try to bring all these concepts together. So in this case, I have taken n value equals to 12. So the total number of subarrays that you know will be 12 times 13 by 2, which will be 78. Okay, now I will be moving top down. So I have sorted all the points in ascending order by end point. Okay, so I'm seeing A on top, which is 2, 3, and let's start processing. So you know that I will be maintaining the first two max S values, right, which is basically the start values. I will be calculating profit at any point. That means profit on removing one particular pair. When I jump to the next pair, then I have to reset the profit again to 0. The blocked will be counting how many subarrays are actually blocked. That means the area of this shaded region. Area of the shaded region will be found in the blocked. And then max profit is trying to maximize the profit that I get after removing each of the pair one by one. Okay, so let's try to do the dry run. In this case, I will be starting with the first point 2, 3. So initial max 1, max 2 values are 0. What will be the max 1 value? Now the max 1 value will become 2. Since the max 1 got updated, max 2 will not be updated. Actually, what happens is, if the new value is greater than max 1, then the max 1 value will be written to max 2, and max 1 will be assigned to 2. Profit will be reset to 0. It is already 0 initially. So let's see. If you remove this A, then how much profit do you get? You find out the gap. Look at the next conflicting pair. Baseline, it is at 5 and this is at 3. So the gap is 2. Gap multiplied by max 1 minus max 2. That means max 1 minus max 2 into gap should be the profit that I get. So what is the profit? 2 minus 0. 2 minus 0 times gap 2 is 4. So the profit is 4. Now if you look at the max profit, it is less than 4. So this will be updated to 4. Now if you look at the blocked number of subarrays, it will be equals to the maximum S value that you have seen. That means max 1 multiplied by gap. This will be equals to the blocked. Okay, so this will be added to the blocked state every time. So you see, it will be equals to 2 times max 1 times gap is 2. So this will be 4. 0 plus 4 will be 4, right? 0 plus 4. So we are done with this point A. Now we will put back this point A in its position and we will move forward. When we reach to B, then you see the B's S value is 4. 4 is larger than 2. So 2 will come here and 4 comes here. We are maintaining maximum and second maximum. You know why we are doing that, right? Now try to remove this B. When you try to remove this B, first you have to find out what is the gap with the next point. Okay, row wise. So the row wise gap is actually 7 minus 5, which is 2. 2 is the gap. What is the difference in the S value? 4 minus 2, that is 2. So the profit that you get will be 4. Now once max 1 is getting updated, the profit should be reset to 0. This means that when max 1 is getting updated, you are getting a new right side point. So you need to remove that rightmost point. You know that, right? Profit will be reset to 0. New profit will be max 1 minus max 2 into gap. Gap is 2. 4 minus 2 is 2. So this will be 4. What will be the blocked cells? These are all the blocked cells, right? So the blocked cells will be the maximum S value that you have seen, which is 4 times gap, which is 2, which is 8. So 8 will be added here. Now max profit will remain as 4 because 4 is not smaller anyway. Now we are done with this part. Now we will go to the next point C. Now C's S value is only 2 and 2 is not greater than 4. In fact, 2 is also not greater than 2. So no update to max 1 or max 2 is going to happen, which means that the profit will not be reset, and even at this point I will be continuing to have more profit after removing B, because how did we get 4? When we calculate B with respect to C, then we just added these two cells as the profit. Now when we reach to C, then I will be adding these cells as profit as well. Okay, how do you do that? Again, you subtract max 1 minus max 2, which is 2. 2 is the gap here. The gap with the next cell 10 minus 7 is 3. So 3 times 2 will be 6. Okay, 3 times 2 will be 6. So the profit becomes 6. 6 will be added and this becomes 10. Okay, 10. And what is the area of the shaded region? This region, what will be that? It will be the max S value, which is 4 multiplied by the gap 3, which is 12. So 12 will be added here. And we are done. Now you see that the max profit is less than 10. So this is updated to 10. Now we go to the new point, which is D. Now you see this D is having S value 3. 3 is not greater than 4, but 3 is greater than 2. So update this to 3. Okay. Now at this point as well, since the max 1 value was not updated, this means that B will continue to add more profit, right? We will be adding this cell here. So what will be the profit? It will be the S value difference, which is 4 minus 3, which is 1, and the gap with the next item E, which is 1 only. So 1 into 1 is 1. So the profit is 1. So this becomes 11. So max profit updates to 11. And the blocked cells, how many blocked cells are you getting here? So these are the blocked cells that you have to add. So that will be equals to the max S value, which is 4, times the gap, which is 1. So 4 will be added to the blocked cells. Okay. And now we can move forward to E. At E, the S value is 7. So 7 will get updated here. This becomes 4. This becomes 7. Now since it was reset, max 1 was reset, that means we are considering a new maximum point, and so the profit has to be reset to 0. Now we will try to remove E and count the profit. So the profit will be equals to the next baseline. The gap is 2. 1 and 2, right? 2 gap. And what is the max 2? Max 2 is 4. So 7 minus 4, which will be 3 times gap 2, is equals to 6. So the profit is 6. Now max profit is more, so it will not get updated. And what is the area under the shaded region? It will be equals to 7 times gap. That means 14. So 14 will get added. Okay. Now everything is set. There is no next point. We are done. So let's see what is the maximum profit. It is 11. So total subarrays are 78. The profit is 11. And what are the blocked number of subarrays? 4 plus 8, 12 plus 12. 24 plus 4, 28, and this becomes 42. So this is 42, and so the total number of valid subarrays will be 78 minus 42 plus 11, which will become, if I subtract 11 from here, so that will become 31. Okay, so this is 7 and this becomes 4. So this is 47 as the result. I hope it is clear. Now in this case, what we did was we have, let's say, m number of points and we sorted it based on the endpoint. So the time complexity there was m log m, and then we are iterating through each of the point and making these calculations in O1. So the total time complexity will be m log m plus m, which will be m log m. And this matrix is never created. This I have shown just for your own understanding, and the space complexity is only due to these variables, which is order of 1. So the time complexity is m log m and the space complexity is order of 1. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the n value and the conflicting pairs. We will find the number of conflicting pairs and arrange all the pairs in the correct order of S and E, where S is less than equals to E. After this, we will be sorting based on the second value, and once you are done with that, we will be applying our algorithm as we had seen. So we will be defining all the variables as I had shown you, and then I will be iterating through each of the point, calculating the start, which is your S value. Okay, then I will be calculating the bottom point and calculating the gap by subtracting bottom with the conflicting pairs at I1. Okay, and then I will be updating the max1 and max2 if required. If max1 is updated, then max2 will contain max1's previous value, max1 will contain the start, and profit will restart with 0, saying that this current item is the rightmost point and this has to be removed now. Okay, once you are done with that, we will be adding the profit as I had explained you and maximizing the max profit. Then I will also be adding the cells for the blocked number of subarrays. After iterating through all the points, we will be calculating total subarrays, and we know that in the total subarrays, blocked subarrays have to be subtracted, and the profit subarrays, that means once you remove a conflicting pair, then some invalid subarrays will become valid. That means blocked subarrays will become unblocked. So those have to be added, and this will be your final answer. I hope this entire approach is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.